A Shanghai cleanroom is now printing 7-nanometer chips without a single extreme-ultraviolet machine, the tool every analyst called the irreplaceable gatekeeper. The pressure that forced that workaround did not come from Chinese engineers deciding to go it alone. It came from the export controls meant to make the workaround impossible. That paradox sets the chain in motion, and the chain runs further than the wafer count suggests. Hua Hong, Biren, a 4-digit wafer number, and the question of whether capacity or capability is the unit that actually matters. The restriction did not sever the chain, it extended it. A second 7-nanometer fab matters less for the silicon it ships this cycle than for the second Chinese institution that now carries the process knowledge, and knowledge, unlike wafers, does not appear on a monthly output report. Start at the confirmed base. Beginning in the early 2020s, United States export controls cut Chinese foundries off from extreme ultraviolet lithography equipment and progressively tightened access to the most advanced deep ultraviolet tools. The intent was to hold the line at a node boundary, using equipment access as the enforcer. Semiconductor Manufacturing International, the largest Chinese foundry, responded by doing what the controls were designed to prevent. It developed a process that uses deep ultraviolet light and runs multiple patterning passes to print features that would normally require a single extreme ultraviolet exposure. Product teardowns and company disclosures confirm that process at the 7-nanometer node. That is the confirmed first link. The controls blocked the shortcut. The foundry found a longer road. Here's where the analogy earns its place, because multi-patterning is genuinely difficult to picture. Think of typesetting a page with a stamp that is too large for the finest letters. Extreme ultraviolet lithography is a smaller stamp, one pass, one fine feature. Deep ultraviolet multi-patterning uses the larger stamp multiple times, each pass aligned precisely to the last, building the same fine feature in layers. You get the resolution, but you spend more passes, more time, and you introduce more margin for misalignment at every step. The physics of the feature are achievable. The throughput and the yield are where the cost lands, and yield is exactly what separates a lab demonstration from a product. That distinction matters because of what happened next. Semiconductor Manufacturing International, demonstrating a multi-patterning deep ultraviolet process at 7 nanometers, was not just a headline about one company. It was a proof of concept for an approach, and proof of concept changes what other institutions believe is possible. Hua Hong, a separate state-linked foundry with its own Shanghai facility, began standing up a second fab targeting the same node using comparable tooling. Industry-facing reporting named Biren Technology, a Chinese chip designer, as an early test customer for that process. That is the confirmed second link. The demonstration at one institution unlocked ambition at a second, and ambition backed by a named customer is a different animal than ambition backed by a roadmap slide. The third link is where the certainty drops to reported. Biren's engagement as a test customer imposed something on Hua Hong that no internal milestone could: a production-grade yield requirement. A test customer is not asking whether the fab can print the features, it is asking whether the fab can print enough of the right features consistently enough to be worth ordering again. That question forces the fab into the part of process development that is hardest to shortcut, the iterative, data-heavy grind of yield optimization. This is the knowledge that Semiconductor Manufacturing International accumulated over years of running its own process. Reported evidence suggests Hua Hong is now on the same clock. The specific yield targets are not public, and calling this a confirmed operational ramp would overstate what is known. But the structure of the relationship, a customer with a real product need engaging a fab on a novel process, is the structure that forces yield learning whether or not anyone announces it. The link the whole chain hangs on is not the wafer count and not the node label. It is the moment Hua Hong accepted Biren as a test customer. That decision converted a process experiment into a production obligation. You cannot satisfy a customer with a process that prints features but fails at yield. Hua Hong is now solving the problem Semiconductor Manufacturing International already solved, but it is solving it independently, and that is the structural shift. The chain hangs on whether that test relationship is real and ongoing, which is reported but whose terms are not public. If the engagement is exploratory rather than a volume commitment, the yield learning clock has not fully started, and the timeline for what comes next lengthens considerably. Capacity projections from industry estimates put Hua Hong's 7-nanometer output at only several thousand wafers per month by the end of 2026. Set beside Semiconductor Manufacturing International's established volume at the same node, that number looks too small to challenge anything. The narrative everyone reached for was a capacity rival. The truer effect runs the other way. The number that seems too small to matter is exactly the point, because what compounds is not the count, but the second Chinese institution that now knows how to reach it. That is the fourth link, and it is reported, not confirmed. The capacity figure is an industry projection, not an operational commitment, and foundry ramps routinely slip on yield before they slip on schedule. But even if the projection holds, the significance is not the volume, it is the distribution. For years, the knowledge of how to run a multi-patterning deep ultraviolet process at 7 nanometers lived in one institution inside China. It now lives in two. A disruption to Semiconductor Manufacturing International no longer disrupts the entire domestic 7-nanometer capability. That is a structural change, and structural changes persist even when near-term output is limited. The fifth link is inferred, and the inference should be held carefully. Process knowledge distributed across two independent institutions is structurally more resilient than knowledge held by one. That inference follows logically from two institutions operating confirmed processes. What does not follow, and what is genuinely open, is how quickly that redundancy becomes operationally significant. Hua Hong has to sustain the process, deepen it, and solve the yield problems that a test-customer relationship surfaces. None of that is established yet. The direction of the chain, toward institutional redundancy, is well supported. The pace is the part that is genuinely open. The most exposed rung in this chain is the capacity figure itself. Several thousand wafers per month by end of 2026 is a projection, and foundry ramps routinely slip. More importantly, deep ultraviolet multi-patterning at 7 nanometers may be approaching a physical ceiling. Each additional patterning pass compounds the misalignment risk. At some geometry below 7 nanometers, the accumulated error may exceed what the process can correct, and no amount of yield learning clears a limit that is set by physics rather than experience. If that ceiling is real and near, Hua Hong learns to run a 7-nanometer process well and then stops. The knowledge still compounds, but on a node that cannot go further. The distinction between learning to print at 7 nanometers and learning to print below 7 nanometers is where this story either continues or plateaus, and that distinction cannot be resolved from the outside until Hua Hong announces its next process target. The second call about this chain is the one that most reporting has not drawn. The process knowledge argument holds even if the test-customer relationship turns out to be pre-production rather than a volume commitment. Knowledge that a multi-patterning deep ultraviolet process can be run at this node by this team at this facility does not unaccumulate when a purchase order is delayed. The yield learning clock slows, but the institutional memory of what the process requires does not reset. What the chain hangs on, and what genuinely differentiates the optimistic reading from the cautious one, is whether Hua Hong's process deepens or whether it stabilizes at a node it has reached but cannot reliably scale. Where the chain leads is not a second Semiconductor Manufacturing International. It is a China where two institutions carry 7-nanometer process knowledge, where the export controls that blocked extreme ultraviolet equipment ended up funding the domestic expertise to work around extreme ultraviolet equipment, and where the wafer count that looks too small to threaten anyone has already done the structural work of distributing a capability that used to live in one place. Hua Hong's output this year is not the variable. The variable is whether its process deepens toward nodes below 7 nanometers or plateaus where deep ultraviolet multi-patterning runs out of room. The Shanghai fab introduced at the start of this chain as the scene of an unlikely workaround is now, in its second cycle of learning, the observable marker of which way the answer goes. The restriction did not sever the chain. It taught a second institution how to forge the next link. Watch Hua Hong's next process node announcement. If it stays at 7 nanometers, deep ultraviolet multi-patterning hit its ceiling and the knowledge compounds in place. If it steps below, the ceiling was a floor. If you want to track where that announcement lands, subscribe and turn on notifications. This channel follows the chain, not the headline.